You know, every single time you pull out your phone, something kind of magical happens. It's this invisible, ridiculously fast conversation that connects you to the 5G network in the blink of an eye. We're going to decode that secret conversation today, your phone's very first hello. Let's get right into it. So, I want you to think of the 5G network like a massive, crowded, and super noisy party. Now, when your phone shows up, it can't just barge in and start shouting, right? No, it has to politely introduce itself to the host. And that simple idea, a polite introduction, is exactly how we're going to break this whole thing down. In this little digital introduction, we've got two main characters. First, there's your phone, which in network speak is called the user equipment, or just UE, and then you have the network tower, the GNB. That's our party host. And believe me, they're about to have a very quick, very structured chat. And that chat, it all happens in 4 lightning-fast steps. The phone gives a little wave, the network nods back, the phone then gives its proper introduction, and finally, the network confirms it heard everything correctly. Let's break down each step of this digital handshake, one by one. So, first things first. Your phone, our partygoer, has just walked through the door. It needs to get the host's attention, but without, disrupting everyone else. So, how does it pull that off? Well, instead of shouting, "Hey, I'm Mike's phone," it sends out this generic, totally anonymous signal. It's really more like a polite, non-specific wave across a crowded room. The technical term for this is a preamble. And all it really says is, "Hey, someone's here and would like to talk." Simple as that. And what's really cool is how that wave actually works. Your phone picks a random signature, this preamble index, from a list of available waves. Just imagine it has like 64 different ways to raise its hand, and it just picks one at random. It also makes a note of the exact time and frequency it's using. This combo creates a unique identifier, the RACH, so the network knows exactly which wave it needs to respond to. Okay, so the network sees the wave. Now it has to reply without adding to all the noise. It can't just shout back across the party because that would just create more chaos. So it sends a very targeted, very specific reply. This reply is called the random access response. And it's basically the network nodding back and saying, "Gotcha, I see your wave. Come over to this quiet corner at this exact time and we can actually talk." It's literally carving out a little private space for the real introduction to happen. And the instructions it gives are just brilliant. The timing advance tells the phone exactly how to sync its clock, kind of like adjusting for the echo in a huge room. The TCRNT, that's like a temporary name tag, just for this one conversation. But the UL grant, that's the most important part. That's the key to that quiet corner, a dedicated private channel just for your phone to send its next message. Okay, so our phone has the network's attention, and it's got a private space to talk. Now comes the most critical part of this whole handshake, the formal introduction, and making absolutely sure there are no mix-ups. And this is the million-dollar question, isn't it? What happens if two phones at the party just happen to pick the exact same way to wave at the exact same instant? The network would only see one wave, but two different phones would think the reply is for them. This problem is called contention, and these next 2 steps are designed to solve it perfectly. So, using that private resource it got from the UL grant, your phone now sends its real introduction. It's not an anonymous wave anymore. Nope. It sends a message that has a totally unique identifier, something that belongs only to your phone, just for this one interaction. And the crucial bit is right here. The phone sends a formal RRC setup request, and tucked inside that message is the UE identity, which is just a really big random number. This is the key. Because if 2 phones were trying to connect at the same time, they would have sent 2 different unique IDs. And here's how it all gets sorted out. It's so elegant. In the final step, message 4, the network basically just echoes back the unique ID it heard. Your phone is listening for this echo. If the ID in message 4 matches the one it just sent, boom, success. The handshake is complete. But if it hears a different ID, it instantly knows the network was talking to that other phone. It doesn't throw an error, it doesn't complain, it just silently drops the attempt and starts the whole process over with a brand new wave. Genius, right? So, after that successful ID match, the polite digital introduction is officially over. Our phone has successfully joined the party. And I really can't stress this enough. This entire back and forth conversation with its random waves, its resource scheduling, its collision solving, it all happens in just a few milliseconds. That's faster than you can blink. It's an incredibly complex dance that your phone performs flawlessly every single time. The end result of all this is that the phone enters what's called the connected state. It's not a stranger in the crowd anymore. It's fully synced up, it has a dedicated line to the network, and it's ready for you to start streaming, browsing, and calling. So there you have it. From a subtle, anonymous wave to a confirmed connection in a handful of milliseconds. This handshake happens billions of times a day, all over the world, completely invisible to all of us. It really makes you wonder, doesn't it? What other invisible, elegant bits of magic are quietly making our modern world tick?